Hello, I'm Eric Snodgrass, and thank you for watching today's long-range technical forecast video brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. We're going to start off with a satellite animation here showing the recent pattern over the last couple of days. And what we're watching in this animation are three key components to the upcoming pattern. First, we do see that there is an upper-level low spinning over parts of the northeast, and that brought in some much-needed rainfall to pockets of the drought-parched northeast. Secondly, there is a vorticity maxima that is moving in the mid-levels of the atmosphere over parts of Iowa, Missouri, and Illinois, bringing with it today a lot of thunderstorm activity and some locally very, very heavy rainfall. Now, places in southern Illinois desperately need this rainfall, and other pockets in Illinois, western Illinois do as well, as does southeastern Iowa. But we'll see how far that rain is going to spread here in just a few moments. But the real part of this pattern that we're going to have to watch adjust is going to be that deep upper level low spinning through Idaho and Montana, and out ahead of it the severe weather that yesterday brought in heavy rainfall into eastern Montana, western North and South Dakota, and we're expecting today again to see this area deal with quite a bit of severe thunderstorm activity later on in the night tonight. So from there, what I want to do is talk about the next week's worth of precipitation. And this is what we're going to be seeing here. There will be temporarily a boundary stalling right in through this area. On that boundary, we're going to be getting scattered showers and storms in through this corridor over the next couple of days. Now, what we got here in the heavy rainfall is primarily coming today in the next 12 to 24 hours. But then what we'll notice here is that as the upper level low brings a lot of stormy conditions to the northern plains and into the Canadian prairies, high pressure will build in toward the weekend over the Great Lakes states. And to its south, all around it, there will be almost like a ring of fire type precipitation that's going to really light up parts of the southeast with a lot of thunderstorms here toward the end of this week and weekend. And we're going to watch early next week for the potential for a low to develop here on that front and push across parts of southern Alabama, Georgia, into Florida, and then eventually get out into the open Atlantic, where it may take on tropical characteristics as it moves onto the east. But what I want to discuss in this particular map are the places that are not forecast to pick up much rain. And in particular, there have been places in Michigan, Ohio, Pennsylvania, this area over here in Indiana as well, that have largely missed out on some of the really great rainfall that we had been seeing across the Corn Belt, for example, for a while. And then getting into the southern plains, this region of the Cotton Belt, for example, we have had a lot of hit or miss storms, but we're forecasting very high temperatures and very dry conditions. Now, out west where things are dry, we're going to pay close attention what the temperatures are going to be doing in the Central Valley of California. But finally, in the forecast, we see a little bit less activity coming through the Columbia Basin, which is going to be looked upon very favorably after all of the thunderstorm activity we've had there. So with this as a backdrop, I want to next talk about soil moisture and drought. You see, where the rains were coming in, bringing drought relief here and drought relief in here, this was good. And certainly the rains are going to help out with the drought in the northern plains. But the big questions that loom deal with what's going on as we go into a drier and much hotter time period over this part of the southern plains. Now, in the Pacific Northwest and the Western United States, we've not seen too much change in the drought here as we moved into the dry season. Partly that's because of the deep troughs that keep swinging through the area, bringing in rainfall. The other part has been, anytime we've brought in heat, it's been relatively short-lived, which means we've been able to keep our evaporation rates relatively low in the west. But how much that drought has changed over the last 2 months is very important to us. So here it is. From April 28th through June 23rd, look at the expansion of drought we've had in a few key areas. Here, the northeast, and the north central part of the United States. Drought is being relieved here, getting some help here before the heat comes in, and then some great help here, not only from yesterday, but going into the next couple of days. So I'll be anxious to see what this new drought monitor looks like. But my biggest concern and the biggest question mark I'm going to have is what's going on in the south central plains. We're going to have to pay close attention to that because the temperatures are going to start to soar. Now, why they're going to have no problem getting into the triple digits is because of the lack of soil moisture. So this is calculated soil moisture anomalies as of June 29th. And remember, when we have such dry soils, we are eliminating one of the uses of the sun's heat, and that is to evaporate water. So if you have water in the soil, about half of the sun's energy could go into just to evaporating that, which keeps your ground temperatures cooler. If the ground is already dry, all of that heat goes into heating up the surface, and therefore you get very hot near ground conditions, and any leftover water gets evaporated quickly. So here's what I want to know. There are places right now, broad sectors in the main U.S. ag belts that actually have plenty of moisture in them. And will that be enough to sustain them through some heat? Here's a couple of different ways to look at that moisture. Over here on the right, I have the last 14 days of precipitation expressed as a percent of normal. And on the left, what I have is a map that shows you for the month of June, total precipitation ranks by climate district. So the closer you are to the number 1, that would be the wettest June on record out of 128 years. And if you're close to 128, that would be dry. Now your eye is drawn to a few areas. For example, here, down here, and up here, I imagine. And that's where we've seen, even over the last 14 days, while we've tried to bring in some beneficial rain, there's this part of Missouri, eastern Kansas, and eastern Oklahoma, and the northern Arkansas that has been exceptionally dry. We're getting great rains coming through this area today, which means this could possibly bring some of these numbers down as we get toward the end of the month, and some rain in the northeast as well. But look at the northwest, very wet for this time of year, and it should be the dry season. In California, although you see the numbers getting up there, in the upper 70s, 80s, and 90s and 100s, we have had at times some decently cool weather, which has really minimized evaporation. Coming to the heart of the Corn Belt, though, there's not a lot in here that is alarming, except for this area and through here. That's a region that I think needs to get quite a bit more precipitation to do well should the temperatures go hot. And they're going to do that. You see, this is our all hazards weather map today. Now, you're probably looking up at Montana first. That is just an amber alert. Out ahead of it, though, we have flood watches here and here. But this is all heat advisory. And this is red flag warning. So the main dry line sits right in between the two. So hot and humid on this side, hot and dry on that side. But windy is going to be our problem. So with this as kind of the setup, where's that heat going? I want to show it to you first by looking at temperatures over the next few days. The highly amplified pattern, remember that deep upper level low sitting and spinning here? Look at what it's doing to temperatures, high temperatures today on Tuesday. Some locations struggling to get out of the 50s. Here in the north central and part of the Rocky Mountains. California, mid-90s, we'll welcome those kind of temperatures this time of year. Where the heat is today is here. Now, the high heat warning area is on the eastern side of this because that's where the humidity from the Gulf is coming up, where it's about drier heat on the backside. But still, heat indices inside of where I hatched there, up to 115 degrees today. So where's this temperature pattern going in the near term? Let's play it forward. So as we get into the day on Wednesday, we start to see a lot of the heat spread throughout the entirety of the Corn Belt, the Midwest, High Plains, Great Lakes states, and into the Northeast as well. Places that are staying closer to normal, the West and the Southeast, okay? But look at the heat that'll be expanding into this area. This is now getting into the 4th of July, much above average temperatures here, averaging some places 7 to 15 degrees above average. We're talking about getting 90s clear up into the UP, into Ontario as well. So very, very warm conditions compared to this time of year. Now, research would tell us that if we're going into pollination for corn, the number we got to look out for is 97 degrees Fahrenheit. If we get a series of days where we get 97 degrees Fahrenheit or more, and there's not much soil moisture, we can really start to see major problems with the quality of the crop. As we play this forward, getting into Sunday and Monday, we still see a lot of these temperatures bordering on those numbers in this region. We're going to be above it here. I think it's going to be quite a bit of heat at times there, not just at this point, but moving forward as well. Because the Weather Prediction Center, or Climate Prediction Center, just yesterday released this outlook. And they have got into this area a moderate risk for excessive heat all the way out to the 11th. The question is, what happens beyond the 11th, the 12th, and the 13th? Do we get any sort of break in this heat? Because what I'm anticipating when you look at this is as you go north, there will be a lot of low to mid 90 Fahrenheit temperatures here, and we'll see hundreds in the southern plains. I do expect to see that. So do these 90s come in with thunderstorms and basically not give us major degradation in the quality of the crop? Or do we get dry? That's some of the questions we're going to answer. Here's what the pattern looks like. It's a bit blocky. You can see an omega flow pattern here, a trough in the west, and a ridge that extends from Arizona all the way up into the Hudson Bay. Downstream of it, a pretty deep trough that's sitting over Scandinavia, and that's going to be critical. That downstream trough I just circled might be the main key in bunching up the flow pattern as we move forward. Now, with any ridge in the middle part of the United States, we have to watch out for where the ridge-riding storms will be. We expect this pattern to make it very stormy in the Canadian prairies in northern United States, and it could be stormy here through the Great Lakes states. But how far to the south that gets, that's the bigger question. As we go out to day 10, we still see similar features. Got it? There's that trough sitting here, and our ridge tends to extend off into this direction with, again, reinforcing troughs off the west coast of the United States. So as we look out from day 7 to day 14, this is what we end up getting. Stormy pattern running around the periphery of the ridge. Canadian prairies, Montana, the Dakotas, Minnesota, Wisconsin. There will be an area in through here where we're going to be seeing much above average temperatures and below average precipitation. My concern is over flash drought. My concern is over places where there's already regional drought development for it to possibly get worse. But places that are going to go into this with decent soil moisture, I think we'll be able to make it past middle of the month without seeing stress on the crop there. Parts of the cotton belt over here in the delta getting over to the southeast, we are expecting it to be quite stormy in this area as well. I'll explain why in just a few moments here. Day 5 through 10, what are the temperatures doing? Well, the main axis of the above average temperatures runs in through here. And inside the area I'm circling, we're expecting to see temperatures 5 to 10 degrees above average. Now remember, to be 5 to 10 degrees above average this time of year, well, it's the hottest time of year. So we're talking about low to mid 90s. Back in the plains, we're now talking mid to upper 90s with some triple digit heat. And we notice that all the way up to day 10 through 15, overall that doesn't change much. The jet stream is north. It's doing something like this, and it is retreated to the north, and that's a critical part to this pattern. I'd like to show you what I'm talking about here. So I generated a map over here on the left, which looks at the climatological average 500 millibar height field. In other words, if it's July, what should the flow on average look like? And if I just trace this out, it kind of does something a bit like this. Now, normally that would give us a stormy pattern in through this area with a lot more heat west. That's typical of July. Where's our ridge this go around? Well, by the time we get to the 15th, it's a little bit farther to the east. And the height lines are biased warm or high. Do you see that? Which means our jet stream has retreated north. We still see the upstream blocking here over parts of Scandinavia. And the question becomes, what does this pattern do? Does it retrograde back west? Does the ridge build west? Does it actually progress and blow on through, and we just can't see that yet in the longer range model forecasts? Is there any similarity between models? Well, here's the GFS. If I go back and forth, just look over there at the image that's on the right. Here's the European, here's the GFS. They both feature a similar trough in this, ridge here, with troughs in the same similar places, but the GFS is a bit more highly amplified, and a key difference is right here. Now watch, GFS has that trough in the Gulf of Alaska. The European doesn't quite see it the same way. It's much closer to the coast. So that would mean if the trough is in fact going to set up here, that the jet stream would peak in a ridge farther to the west, northwest flow comes through the northern plains into the Corn Belt, and we'd see a lot of thunderstorms. It'd be a hot and wet summer here. But when we talk about all these different ensemble forecasts, I want to make sure you know what we mean. You see, the GFS is run 20 times plus a control run. The European's 50 times plus a control run. Each one of those ensemble members is seen here in a different line. Now, the lines represent the 500 millibar heights. And as I press play on this, you can see the spread in those lines change as we go forward in the forecast. Certainly on Saturday, look at this. This is the 588 line right there, or the 5,880 meter line. And it is showing us, it's advertising the big time heat that's moving into our 4th of July weekend in the midsection of the country, while the trough pulls into the west. See it? As we play this forward, though, notice the spread in the ensemble members as we work our way out into next week. As we do that, you can see the ridge that breaks down big time right here. And that's got me concerned during this time period of building higher atmospheric pressure, thus limiting Gulf moisture as we work our way past this weekend into early next week. But with time, the models, although they show quite a bit of spread, the GFS and its ensembles want to build the ridge by mid-month back to the west. And if that occurs, we'd get more northwest flow and then a better chance at seeing a stormy but hot summer pattern in the midsection of the United States. This would mean the west would go over warmer and drier. So now that you know what I'm talking about when I say ensemble spread, let's look at it another way. We look at teleconnections, right? On top I have what's called the East Pacific Oscillation, and on the bottom I have the Pacific North American pattern. Now the EPO is going negative, and what that means is we're going to be seeing more troughing along the west coast with ridging in the mid part of the country. And as that happens, you notice that once we get out past the 9th, the EPO is signaling that the North Pacific is going to trend possibly back toward average. What this actually means is there's enormous spread in the forecast, and we're not quite clued into what's going to be happening in that area. The Pacific North American pattern does this. Whenever it's below zero, there's a trough. Ridging when it's back up near zero or above it, and then another trough. So this is the heat wave for the weekend that we're building. This is the heat wave to begin next week. But does the PNA keep doing this? Does it keep dropping back off? Because if it does, that is significant for understanding what the rest of this summer is going to be. I'm going to draw a big question mark here as well, because I don't think at this point the models have a clue beyond day 15. Let me show you what I mean. The latest European ensemble was released last night for the long-range outlook. They run what we call a weekly product. And when we look out here, this is for the end of the month of July. Now at that point, the European model wants to put the high-pressure cell here and wants the flow of the atmosphere to do this. And if it does, you get this pattern, stormy, right in the heart of the country. That's what northwest flow would bring you. It'd be hotter and drier here, which is no good for the southwestern monsoon. But it would be stormy in the midsection of the country. Thus, any hot, dry conditions we're dealing with in the near term could be relieved at the end of the month. But I think there's so much spread that the model is actually trending toward climatology, and I'm asking myself, is this really the way the pattern's going to evolve? That's the trickiest part of this. So I need to tell you what I'm going to watch out for. We're going to go back to this concept of atmospheric angular momentum. We know that the momentum fell off over the last month, and it's done it primarily due to losing momentum in the southern hemisphere. Now, this is a new diagram I don't often show you, but I look at every day. This is the equator, and so you're now south of the equator here, and north of it, of course, north of that line. The values, let me get my drawing up there, these values right in through here mean slower than normal winds, and these values would mean faster than normal. So all the momentum loss that we saw was down here south of the equator or in the tropics. What you need to watch for is if we see that same feature showing up here moving forward. That would mean a collapse of the zonal flow in the jet stream in the North Pacific. Things would get blocked up and very hot and very dry. Now at this point, we don't necessarily see that occurring. At least it's not advertising that it's going to occur very quickly here. But we're going to have to watch for it very carefully. Other components to this flow that are quite challenging. The MJO. It came out over here in phase 3 back in May when screaming around like this to get into the beginning of June and has since stalled out right here in phase 1 and 2. It's been a standing wave over Africa. That means the best upper level motion has been over Africa, which is here and here. Now the sinking motion that we've got here is completely throwing what could have been a developing La Nina out the window. What am I talking about? Well, because of the MJO doing what it's doing, it has helped send the Southern Oscillation Index down here to almost -8. That's down here, meaning we're looking at more like what we get when there's an El Nino going on with our pressure and wind patterns across the Pacific. Remember, La Nina is up here at +7 or above. That's La Nina. Where are we at? Right here. And so if you notice, we are starting to see some trade winds, stronger trade winds showing up. But there's still a westerly wind burst happening at 120 west, then going to the east. So by the way, where I'm circling right now, you can see that the winds are diverging. And if they're diverging near the surface, the air must sink above it. And that's why we have this sinking motion in the atmosphere over this area. Right now, La Nina isn't in control. The MJO is. This La Nina is weak. Technically not even really there. Let me show you what I mean. Over here in this graph in the bottom right, the ocean temperatures in Nino region 3.4, which is inside the box I'm currently drawing here, can't seem to get below -0.5. In fact, they've moved back up to average. What is incredibly unique about this pattern are two other pieces to it. One, we saw the Indian Ocean dipole skyrocket into positive territory last fall for the Northern Hemisphere and then drop off as we approached January and February. Most model forecasts kept it down here because of the developing La Nina, but instead it shot back up, which means warm water here and near average water there. That's not normal. That doesn't tend to go with a La Nina. Neither does this. Warm water here. You see, the heat that's been over Siberia, the heat that's in the North Pacific has pushed the jet stream north. What I've been arguing is that I think we could get a hot stormy pattern, which is a rare combination because of these inconsistencies in the teleconnections around the world. Now, am I right? Probably not. I mean, this is going to be a pattern where there's a high rate of failure. But I'll just make my last few points, by telling you this. If this summer is going to remain for the central United States hot and stormy for the main U.S. and Canadian ag belts, that ridge will need to move to the west. Now, some folks in the west would welcome it. Bring in the heat. Some of the crops need it. And we want to get rid of these frequent rainfall events, which are hindering some of our tree fruit. It's also impacting hay harvest. And building in some heat at times in summer is good for our western U.S. crops. But I'm going to tell you something. If you've noticed me talking about the west, all model forecasts of sustained heat in the west have failed to this point. If the summer turns the opposite of this, hot and dry, keep the ridge anchored over the Midwest to the Great Lakes. That will put a big surface high pressure cell in the mid part of the country, blocking Gulf of Mexico moisture transport, and we would quickly get rid of our soil moisture profile and have flash drought. Okay? Now, we haven't seen something like that for a long time. Those are the two big ifs. What are the wild cards? If we do, at the end of the month of July, go back over into a stormy pattern, which is possible if the ridge moves west, can the moisture that's currently in the soil in the mid part of the United States sustain it? Certainly, we don't have that moisture in the southwest, which means I do anticipate through the next 15 days drought expansion in the southwestern United States. Could tropical systems offset any of this? I don't think so. We don't right now have the best conditions for tropical systems to develop, partly because of that dry, dusty air. But this is what I would tell you to look out for. On the 4th of July, about a mile above our heads, much above average temperatures, that's the cooler pattern here in the midsection of the United States and of the Great Lakes. There will be a high-pressure cell sitting there, and the flow around it is like that. That is one that blocks off the Gulf of Mexico, and that's why you see there's going to be problems with this area going over dry. But storms will run around the edge of this, and we'll get storms in the Canadian prairies and north-central United States. By July the 9th, though, we notice that the models are trying to return plenty of Gulf moisture. That to me would say, okay, if you're going to bring in the moisture from the south and it's still going to be warm, it's going to be a hot and stormy pattern in through here. Notice that all the way through July the 9th, the west seems to be carrying a cooler bias aloft. By mid-month, we still see the atmosphere not shutting down the Gulf of Mexico transport of moisture. We then see the models advertising heat building west, which may suggest the ridge moves that way. And if it does, you end up getting convergent flow in through here, and that excites thunderstorms. So that's why I've been building this case. At this point, my confidence is low. I do not have a solid picture on how the rest of July is going to favor, but I will tell you this. The jet stream is north, more north than it normally is. The heat will likely be on. My concerns beyond this, into the month of August, could possibly be centered on having very warm overnight low temperatures, which could stress crops as well. But we've got a lot to watch evolve before we get there. And the teleconnections right now, which are not constructive in their nature, have reduced our predictability. So these are the things I'll be watching carefully, and I'll report back to you as often as I can. Hope you all have a great rest of your week. I hope you have a great 4th of July weekend, and we'll talk to you again soon. Thanks.